second or third talk we've had, but this is the big one we've all been waiting for. So Don is our education officer, and he has a very impressive career behind it. Don is basically a hydrologist. He did his PhD on the groundwater ecosystems of the Swan Coastal Plain, and he's been worked a long time in organisations like Department of Water and CSIRO, and he's a very active adjunct professor at UWA at the moment, and also our education officer. So he's been looking for an excuse to learn more about Perry Lakes, and this is the excuse, I think. So welcome, Don.
Thank you. Thank you. Okay, well, I think you probably know Perry Lakes as well or better than I do, but I'm hoping that I'll be able to give you a bit of the hydrology. So I'm not going to be talking a lot about the birds or anything like that, but it's very much to do with the water side of the Perry Lakes. These are some images that you're probably well aware of. You know, the terrestrialisation, the trees growing through the bed of the lakes, they were recorded in a thesis in 1980. So there's over 40 years of tree growth in some of the parts of the lakes, the bed of the lakes. You're probably aware that also for about a 40-year period, the town of Cambridge has been augmenting the water levels, particularly in East Lake, by pumping in groundwater, which is that central image. The solution to the lower water levels is to bring water down from the Herdsman main drain. And there's a photograph there of that main drain as it flows past Newman College. And it's all connected up, ready to go. As far as I'm aware, they haven't switched any pumps on. But it's able to, and I'll talk a bit about that scheme in a few minutes. The other thing is that I did some, as Nikki says, I used to work at CSIRO, so I used to walk around the lakes a lot, and it used to be fairly common to see the southwest snake-necked tortoise turtle, I should say, walking around the lake occasionally sometimes. They're becoming harder to see, but I was very pleased to see that Rob Woodbury from CSIRO recorded one just last year. So they are there. The status of them is little known at the moment, but maybe we shall get through the Friends of Perry Lakes and UWA and others. We'll get some studies in future to find out what their status is. Okay, so I'll operate this thing. I'm going to try and cover 10 areas. So this is a bit to pace you, if you like, and I've got some sections headings there. So if you're wondering where you are in this talk, we're going to try and cover 10 areas. The first thing is, how did these lakes form? And there's West Lake, East Lake, South Lake, which people don't know much about, and Camel Lake. So there were 4 lakes there originally. How did they form? How have they been altered, particularly? We've got some information on that in the talk. What's happened to the lake and the groundwater levels over time? I've got some data and some recent data on that, particularly from the Department of Water and Environmental Regulation. How do the lakes relate to the confined aquifer, sorry, the unconfined aquifer, the superficial aquifer that's underneath them? How do they relate to the surface water drainage systems around, both to the north and to the south of the lakes? What's the water quality in those drains, also in the lakes, and also what's the water quality in the groundwater? I haven't got a lot on that at the moment, but you can see I'm trying to cover a large area, so I'm trying to keep it fairly tight as to what I'm covering here. There's a very small amount there about the quality of the flora and fauna, because there's been some work done by the town, particularly. I should acknowledge that some of the fair bit of this information tonight has resulted in the town doing a number of investigations prior to bringing the water down from the Herdsman main drain. I'm going to cover a little bit the current proposal to increase the lake levels, and then I'll try and identify some major unknowns and some ideas of how we might address those unknowns and draw it all together with some conclusions. So the first section is, how did they form? Now, if you look at a map of the lakes on the Swan Coastal Plain around Perth, you can see that a number of the lakes clearly are formed between 2 dunes systems. They're very, very long, thin things, so that the dunes are reorientated parallel to the coast, and the lakes are just in the low-lying parts between dunes. And they're, the very common ones, Lake Joondalup and Goolalul, and there's another lines of dunes out here as well. We're down here, we can just barely see Perry Lakes here. They're not obviously interdunal swales. They're not sort of lakes formed between 2 dunes, obviously. There's 2 other reasons you can form a lake, and one is that you can get wind can actually blow out or deflate an area, so it can move the dunes around and can create a low-lying area. And when the groundwater levels rise, they can actually intersect that low-lying area, and then you can get a lake formed in that area. That's the second way that you can get a lake formed. The third one, there is Tamala limestone running along the coast here, and it's underneath this part where we're sitting at the moment. So what you can get in limestone situations, the groundwater can dissolve the limestone away, and then you can get sinkholes forming. So they could get a lake where a sinkhole is, and the geologists call these dolines. So basically, they're the three main ways that lakes can form, or there could be a combination of those. So what I've got here is some data from John Rich's thesis. The guy did an incredibly good thesis, and he published it in 2004. It's online, every chapter there, and it's one of the best theses you could ever hope for. And it's really underpinning a number of the slides I'm showing tonight. But he's basically said that his opinion, I agree with him, is that they are wind deflation basins. And you have to understand a little bit about the geology of the area here. So we had a series of ice ages. During those ice ages, there's very little rainfall. It becomes very arid. It's very cold and arid. And at that time, the dunes would have been blown around a lot by the wind. So the sand would have been blown around. So the thinking is that towards the end of the last ice age, when it was very, very dry, about 12,000 years ago, there would have been, the lake beds would have been carved out through wind, and they would have been about 3 meters below where they are, where the current land level is. Then, of course, after the ice age, the sea levels come up again, and because the sea levels come up, the groundwater levels come up as well on land as well, and the rainfall increases. So basically, we've got two things there. We've got the formation of the basin that the lakes are in, and then you've also got the formation of the lakes, which means that the groundwater comes up and fills those basins up. Then for the last 8,000 years, we've had various periods when it's been slightly wetter and slightly drier than in the past. In John's opinion, it was mainly perhaps drier than wetter for large parts of that time. But there were certainly some very wet periods and some times when the sea level was even higher. So in those times, the Perry Lakes would have been very extensive. So all the lakes would have been connected up. So Campbell Lake, South, East and West Lake, also all to be reserved flats would have been all underwater in those periods. And there's also at those times, McLean Park and Floret Oval, which are also low-lying areas, would have also been lakes. So there would have been periods when there were very, very extensive lakes, and other periods when there was just what they call sumplands. So they would just been swampy areas. Now, since John's work, there's been some other work done, and I'm trying to, on all of these slides, I'm trying to put down, if you wanted to go back and read more about it, where that's come from. But Tony Smith and some colleagues at CSIRO looked at seeing whether there was evidence that the limestone had been dissolved, and we've got what we call a karstic system in the Tamala limestone. And they did do some drilling under Perry Lakes. And there is one area here, you might be able to see it, between about 11 and 13 meters, which is very, very high. There's a lot of water in that area, so there's a lot of this evidence of some dissolution of the limestone, but not a lot. You know, there's no big caverns underneath this area, but there's possible that there has been some dissolution of the limestone underneath the lakes, and there may have been some slumping, but it's certainly, almost certainly a windblown feature for which there may be some additional slumping because of limestone dissolution. So we've already got through one section, so congratulations, we're up to section 2. So how have they been altered? And again, I'm going back to John on this one, and he's been really good at getting lots of aerial photography and gone back, and this is just one of them from 1942. I particularly like this one because it does show the 3 lakes, and here's South Lake. So there was another lake here that was actually filled in. In fact, I think it's probably where about the playground is now at the moment, or even the toilets. So there was, and if I'm to tell you later on, I'll show you which year that was filled in, but it was basically not as extensive as West Lake and East Lake. But there's also this photograph from January 1942. You can see these trees that have been planted around here. When I spoke to John, he said he was told that they were planted at the centennial of the settlement of the Swan River Colony. So they were planted in 1929. So these are the trees here, and we run past them. Those of us that do park run, we run past them, and I had no idea until I read John's thesis that these were actually probably heritage trees. And so we're coming up to the 200th anniversary, sorry, of sorry, was it like the 100th? There should be the 100th anniversary of the settlement. Sorry, that's why everyone's looking a bit puzzled. It's my typing. But you can basically see that the lakes in 1942 were fairly dry as well. There's quite often there's separate basins in them as well. There's been a lot of work done on the bathymetry of these lakes, and they've been altered a fair bit, but the basic bathymetry is still there. So where there are sub-basins, they're still there. So now we're going to step through a few slides to just give an idea of how they've changed. And these are also from John's thesis. So if you go back to 21, which he's got an aerial photography from, you can get some idea of the shape of the lakes. They're not perfect ovals like we are used to now. They were actually quite irregular. And he's got some areas where there were permanent water. This is the 42 one that we've just had a look at the aerial photography from. You can start to see that once we were going back, once we were starting to get close to the time when the Empire and Commonwealth Games was held, they did major alterations. So in 1962, 22nd of November 62 through the 1st of December, the Commonwealth Games were held. So there was a lot of construction that was happening here in the late 60s. And at that stage, they reformed the lakes. They actually made them into much nicer, or much more uniform, if you like, that shapes. They also made the beds much steeper so that they were much shallower before. They also started putting stormwater. So as the residential areas developed around Perry Lakes, they started bringing in stormwater. And you can see South Lake is still there. At the time of the Commonwealth Games, South Lake was still there, but you start to see that they're starting to alter it. What I should point out, these stippled areas are where there was reeds and rushes, basically of different genera. So you can get an idea, these areas are getting quite shallow. Then going through from 63 through to, what's this, 84, you can gradually see more and more alteration occurring. South Lake was still here, but it was filled in by the time that an aerial photography was taken in 1967. They started connecting up the two lakes, so that one thing you should know about the 60s was that they were particularly wet, and so there's great concern about flooding. The lakes got very full. There was lots of flooding of the Alderby Reserve. So this is the water, what would be the Metropolitan Water Authority at that stage, connecting them up. You can see that they've put a pump station here to take too much water away. So this was a time in 67, the first time the pump stations occurred. They've started creating some artificial islands as well, and basically making them much more similar to what they are today. And these are the last pictures that from more recent ones, and they're basically showing how the terrestrialization I was telling you about before, as the trees have come in and the open and water areas have gradually got less and less, particularly since the 60s. So we're up to section 3, and I think it'd be interesting, if you're interested, I'd really recommend you go and have a look at those aerial photographs that John's got there. They're an amazing resource. So now we're looking at the levels. What's happened to the lake levels? I said that they were very high in the 60s and perhaps before that, but they've got much lower, of course, in recent times. But first of all, I want to take you through a little bit of hydrogeology. So these contours here are the elevation of the top of the water table. So groundwater flows downhill just like surface water does. So back up here, we've got 13 metres above sea level. So this could go all the way back up to the top of the Nangara Mound, where it's about 70 metres above sea level. But at Lake Munga, it's about 12. You can see that water that goes out of Lake Munga will go down a flow line here and it'll come into Perry Lakes. So these are Perry Lakes here, West and East Perry Lakes. You can see that they're between the 2 and 3 metre contours. So this is how flat, if you like, the water table is, and the fact that we're only 2 or 3 metres above sea level in this area. So we're pretty close. If you're starting to worry about that's getting pretty close, maybe salt water can come in. Down to Lake Claremont here, we're down to about 1 metre above sea level. So they're very, very, and it gets even worse if you go down into the Mosman Peninsula. It's less than a metre sea level. So that's why they're very concerned down there about salt water coming in. But basically, I've gone back and looked at the Perth Groundwater Atlas, which is online if anyone wants to have a look at it, looked at some of these levels again, and they are not that changed, that significantly changed from when John Rich grew up this flow net. But we'll start to look at, or each of these little crosses here is a level that is used to create this flow net. And you'll notice that there's a whole lot of crosses flowing down the flow lines, if you like, across both West and East Lake, which is what the monitoring that particularly that John did, that I can show you some data on a little bit later. So this is West Lake. On the vertical axis, we've got the water level above sea level. So this is how many meters above sea level we are. And this is time. So it's going back to about 1950 and up to 2000, which is when John finished his thesis. But you can see that there are high points above 5 meters in the 50s. And I said that there's, it was still very high in the 60s. But you can see this very, very steep decline. Basically, we've had about a drop of about 50% if you consider that we're now about 2.5 meters and it was about 5 meters. So the gradient between the lakes and the ocean is now half of what it used to be, which means that the flow between the ocean, with the lakes and the ocean, is now probably halved as well. So this has gone down to about 2000. I've supervised a couple of students, Alice Drummond in about 2010 and Claire Tennant in 2017. And they've actually done some measurements as well. And you can see that that did decrease, particularly for West Lake, did decrease. Now, the thing is that there's a couple of lines on here. When the lake basin's completely submerged, when it was about 3.6 meters, and the basin is completely dry when it's about 2.4 meters. So in between these two, you've got emergent lake bed. So, and again, John said for East Lake, which is the other lake, since about 1995, the summer water table has now been below the bottom of the lake. So that's really important because it's actually saying what the connection is between the aquifer and the lake, as to whether they're connected or not. Okay, so the town has done some monitoring of the levels in the two lakes since that, when we finished in 2000. So about 2005 to fairly recently, we've got levels from the West Lake and from East Lake. And basically the levels are just very close to, as you have observed, the levels they go up a little bit in the winter when there's the runoff comes off the roads, the levels go up, but in the summer, the whole system dries out pretty well. So you just get the lake bed exposed, except where it's topped up with groundwater. So we can think of the lakes as being perched effectively. So the water that comes in from the stormwater sits on top of the clay and the peat, and it sits there, and it gradually, when that stormwater doesn't come in anymore, it gradually soaks in or evaporates, goes through that peak, and then gradually gets added to the groundwater that's now a metre or so below the lakes in some cases. So we've had, John again was saying that there's been a number of years, 93 was the last time he'd seen water completely over West Lake. Well, I think we actually saw it back last year. So last year was exceptionally wet, relatively, compared to what we're used to. When I looked up at the Bureau of Meteorology, they said it was 150 millimetres above normal. And in that year, we've actually had, for the first, one of the very few times, we've had water level over the whole bottom of the lake. Unfortunately, I haven't got those levels, but I'm pretty sure that the town will have them somewhere. They can get water levels also from the Department of Water and Environmental Regulation. And what I've got here is these three here. Water levels of groundwater very, very close to the lake. So this is not lake water levels now, these are groundwater levels near the lakes. The red, I'm pretty sure, is continuous logging, and the blue is where they've taken the manual measurement. So you can see that there is a bit of a decline occurring to 220, but we've got 221, one measurement where it's taken it right back up again. So the groundwater levels did recover pretty well in that wet year that we've had. Now that's only a 3 or 4 year period. There is a bore. Those of you that walk the Zamia Trail would have noticed that there's a bore as you go around right in that southwest corner of the Bold Park area. And this is a long-term monitoring bore. And you can see this decline that occurred. This is 1978 all the way through to recently. So it's gone all the way down, but in about 2010 or so, it seemed to have stabilized to some degree. And you might almost say, if you only looked at this last, 5 or 6 years or so, you would have actually think that there might even be a slight increase there. If not, definitely you can say that the rate of fall is steadied off, particularly there. Now, Steve Easton, thank you very much for collecting data for the last 10 years in Bold Park. So these are data that has been taken from the bores. Again, you can see them when you walk around the Zamia Trail. You would have seen some bores there that Steve's been monitoring for the last 10 years. So this is going back to 2011. And we've got 1.5, 2 and 2.5 metres and 3 metres above sea level. And you can see that there has been, in that last 10-year period, at least there's no continuation of the decrease in levels. So we've actually almost got that very steep decline that John Rich has been observing. He seems to have equilibrated for some reason. And without labouring the point too much, this is some data that's come from the Department of Water and Environment Regulation. We're in this area here, which is blue, which if we look across here, this is over a 20-year period, is about a 0.6 to 1 metre rise. So there's large parts of the western suburbs where the groundwater rise has ceased, if not, it's started to come back up again. So that's some good news, because before I looked at a lot of this data, I got the feeling that the drying climate had meant that we will just, we would be continually chasing this groundwater levels as it keeps going down. But it looks as if perhaps for the last 5 or 8 or 10 or more years, we've actually had that decline reduce, if not reverse. So we're up to section 4. How do the lakes relate to the unconfined superficial aquifer? So I'm assuming you know a little bit about the groundwater system, but basically we're in a system of sand dunes. The rainfall that comes in soaks through the sand, goes into the aquifer, so there's direct recharge into it. Underneath these sand dunes, there's some clay. So we've actually got an unconfined groundwater system, which most people who've got backyard bores will be tapping into. And of course, the council takes pretty well all its water from this unconfined groundwater system. So the classic thing is that everyone has assuming that most of the lakes on the coastal plain are what we call through flow lakes. And here's a classic one. You see this blue oval here, that's the lake. The groundwater comes in from the upstream side, it gets captured by the lake. So the lake starts to capture all the groundwater. The groundwater flows through the lake, and then there's a release point at the back. So this is this other part of green here. So this is what happens in lakes like Joondalup and lots of lakes on the coastal plain. It would have been the case of what was happening with Perry Lakes as well. It would have been a through flow lake in that the groundwater would have flown through the lake. That's what it actually means. And here's a typical one, which is a Lake Nowagup. So you can see the groundwater actually gets captured. Even though the lake is very thin, the groundwater comes up from some distance from the depths, goes through the lake, and then on the downstream side, you get salty water, not salty water, I should say more saline water leaving the lake, because what happens is when the water's in the lake, it becomes slightly, the salts accumulate a little bit through evaporation. So it's a bit denser and it goes out to the bottom here. So is that the case for Perry Lakes? Now this is quite a complicated little diagram, but I'll walk you through it. You can see this dotted line here, that's West Lake. And you can see this line here, this area here is East Lake. Now, if they are through flow lakes, then the groundwater flowing along these flow lines would be being captured by these lakes. But actually, if we look at them, they're being captured by these little crosses here, which are pumping bores. So these are actually the bores that the town used to irrigate the area around the lakes. So that the groundwater is not being captured by the lakes, they're being captured by these pumping bores. So the pumping bores are lowering they've got a cone of depression around them, if you like. So it's, I don't know whether everyone can see, perhaps at the back you can't, but there's a great cross section through here. The blue here is the lake. It's actually sitting up quite high. And this is because this bore here has been used over the weekend to top up the water in the lake. So we've been actually, the council's been operating the bore here to top up this lake level. But you can see the drawdown, once they start irrigating from for the grasslands around it, they draw down the water levels around the lake. So effectively, we've created a great gradient between the lake and the aquifer. So the way John summarises it quite well is that the lake's maintained by persistent pumping. The harder the pumping, the greater the groundwater gradient between the lake and the bores, and the faster the water drains out of the lake. So basically, it's a circular system is what's happening there. But the way that John, and this has been recorded in the late 90s, the groundwater level is now quite some distance below the lake. So this is why I was telling you early on, it's a perch system. It's no longer a through flow lake system. Now, so he also says that the East Lake has been progressively separated from the water table for about 30 years and West Lake probably for even longer. So this is quite important because you know, what happens to the groundwater level and what happens to the lake level, and there's a bit of a decoupling between the two. Now, if you thought that was complicated, this one's also a little bit complicated, so I'm really making you work hard for a Sunday. This is actually the fluxes of water that go in and out of the lake. It's worth spending a little bit of time on this because it actually tells you a lot about what's happening in the lakes. So you can see that we've got a water budget here, and the higher it is, the more the water is going in and out of the lake. And there are times of the year, times of these water balances where there's very little water going in and out of the lake. So let's take these first four here. This light blue area here is top-up water. So this is where the council's pouring water into East Lake. And the dark blue here is how fast it's draining out. So basically, as fast as they're putting it in this water level, within this period, it's draining out. And that happens for the first four of these. This is the main thing that's happening. Then in winter, you get a lot of stormwater come off. So this is this dark green. So this light green here is rain that's falling directly on the lake. The dark green here is runoff, just like we've been having the last few days, really, running into the lake. And again, the dark blue is water draining out to the bottom. So basically, we've got two sources of water going into the lake, mainly, apart from the rain that falls on it directly, is the drain water that's coming in and the pumping water. And just about all of it, apart from the bit that evaporates, goes out the bottom into the aquifer. So the lakes are actually recharged for most of the time, as far as the groundwater goes. So you can, you know, I won't dwell on it. The only times that John was able to, in the 90s, pick up any idea when there might have been groundwater coming into the lake is these little bits of yellow here, but you can almost see that they're almost negligible. Is there much groundwater coming into the lake? So we're almost halfway through. Section 5. How do the lakes relate to the surface water drainages? Now, this is a bit fuzzy, I'm afraid, but here we are down here. We've got West Lake and we've got East Lake. This is Herdsman Lake up here. Herdsman Lake is a very, very important drainage system. These are the main drains. These aren't the street drains that the council manages. These are the main drains that the Water Corporation manage. So you can see that the Herdsman collects water from way across the other side of the freeway, comes all the way down. There's Jackadder, it comes down into Herdsman. There's also lakes, there's also drains that come in from all around the lakes. And they come out here, they go past Newman College, and then they go under the golf course. You know, there's a big pipe there now, which was excavated, and it comes out onto Floreat Beach. So you will all see that pipe coming out onto Floreat Beach. So this is the catchment area for the water that the council's going to be bringing down to the lakes. So it's mainly, this area particularly here is light industrial area. So it's coming out of light industrial area, going through a large lake, and then going out to the boat, to the ocean. Perry Lakes, which is down here, is actually part of the Subiaco surface water drainage system. So it's also a main drainage catchment. And, you know, I mentioned that there was that pump station that's just here on the southern part of East Lake. It pumps, when the water levels get to a high enough, the pump brings it down here. It connects on to this, the Subiaco drain that comes out here onto Swanbourne Beach. This also, if you trace it all back, goes up to Lake Juleba. And so that's where it all starts from. Okay, now there's a great, and I've got here, this map has come from a study that was done in 2007, which was looking at what's the water quality coming out of all these drains that go onto our beaches. And it was a great study and gets very little mention. And you know, it's really quite important to know what the quality of the water is that's going out, because this doesn't dump it into the ocean, way into the ocean. This dumps it right on the ocean. It right where everyone's swimming and fishing and things like that. But it's a good one if you ever want to watch. Now, sorry. Now, so here we are. Just to orientate yourself. So here's our two lakes. So now we're looking at the Subiaco main drain. And here's the pump station here. This is a connection that goes down to the Subiaco drain. So this is the one that goes back up to Julebuk and things like that. Now the catchment area, that's the area of all the roads that run particularly into Westlake, goes all the way up to the boulevard. Doesn't mean that there are street drains that go all the way up to the boulevard, but all the water that comes off the streets go up there. So so this is the idea of bringing water down from the Herdsman main drain was actually an idea initially had by the Perth City Council before even the town of Cambridge was formed. The idea was that if you only get the water from the Herdsman main drain over the catchment divide, you can just let the surface water system, the normal drainage system, the road system, if you like, bring the water down into the lakes, which means you don't have to have all the pipes going all the way down, which was quite brilliant. So I just got a little picture here of the pump station. I don't think it's been operating since about 1980. So we probably, in fact, a lot of these old pump stations, they take the pump away. One thing they don't take away is your drainage rates. I'm pretty sure if you lived in that catchment, you'll be paying, if you look at your water bill, you'll probably find you're still paying drainage rates, though that pump hasn't operated for over 40 years. No, I didn't tell you that. So we're up to section 6. What's the water quality in the drains, the lakes, and the nearby groundwater? So going back to this study again, this one was 2007. I really like this study because actually they looked at not only what was coming out of the Herdsman drain, they compared it to all the drains from all the way down south of Rockingham and all the way up to the north. So you get an idea of how good is the water quality coming out of that drain compared to others. And it's interesting that some of the microbial standards were actually much better in this drain than on the other drains, which was a bit surprising, but there's a reason for that. What was different about the drain was a very, very high in nitrogen. And they've explained it basically because this is actually a drain that takes a lot of water away. So it's because it's taking groundwater, it'll flow throughout the whole year. And large volumes mean that you actually can dilute things. So there might have been lots of bugs, there might have been a fair bit of metal there might have been a fair bit of nutrients or phosphorus and things like that, but there's so much water that the concentrations are not very high. That's really okay if you're worried about concentrations, but of course, if you're putting it into a closed system, it doesn't matter so much. You're worried about what's called loads, which is how many tons are coming in. It doesn't really matter whether it's coming in very low concentrations. If there's a lot of water coming in, it's bringing in a lot of stuff, basically. And it's particularly important for phosphorus because the loads, phosphorus builds up over time. Nitrogen, you can get rid of nitrogen. You can burn it off as a gas if you do things right. But phosphorus is not quite so easy. So this is the picture of obviously the drain as it goes out onto the beach at Florida. So now I'm going to look at the water quality in the different lakes and how they might change, particularly as they bring the water down from Herdsman. So the thing is that if you look at water quality in the lakes, you'll actually find that in winter and spring, water quality is very good. It's very fresh because basically it's just runoff from the roads. And the road runoff in Perth, it's been measured a number of times. It's actually quite good quality. There's not a lot of, you don't have a lot of oil and fertilizer and things like that. And it's not too bad. They even sweep the streets around here. So it's actually quite good quality. It's very low salinity water that goes into that lake. But what happens is over the summer, as it sits there, then the peat that's at the bottom starts to decompose. It's mineralized. It gets oxidized, if you like. And there are some snapshot samples that have been taken by the town, and they've actually picked up a few small things, not very much, high nitrogen, low dissolved oxygen, and in one case, high phosphorus. But this is after many, many measurements. So really the water quality is very good. It doesn't look quite so good perhaps towards the end of summer, but it's still nothing really too worried about. Just because I've been going around a few times, there's been a little bit of, towards the end of summer, you can actually see some algae sometimes in that, if there is any water there. So there's a bit of evidence there could be some algal blooms. I know they've had some problems with mosquitoes at one stage as well, and had to spray around some of those areas. Now, once the Herdsman main drain water comes in, the salinities will increase because that's mainly groundwater. So it's probably going to be in the hundreds of milligrams per litre rather than the tens. So the salinities will go up, and probably the nutrients will come up as well in the winter and spring, particularly because that's when they'll do most of the pumping. This picture here, I should have pointed out, shows three things. This shows actually where the water will be coming in. So this is where the pumped water will come in. This is the northern part of West Lake. You'll see some sedges being planted down here, probably Balmia articulata, I think it is. There's been extensive plantings that have been put in. And you may also notice there's a little sign up here saying, do not go near this water because there's been a sewage spill. I'm still trying to find out from Water Corporation. The last 2 years, they've had 2 spills into the lake. I haven't been able to find out from them how much they think went in, where did it come from, is it likely to happen in the future? They haven't got back to me yet. But I suspect they're fairly minor. It's probably that the sewage system they have outlets for them if it gets overloaded, and it probably spilled water onto a road and then it comes down through the road system into the lake. But it's still a bit of a mystery. So that's what was happening in West Lake and East Lake. Again, we've got in winter, we're getting a lot of runoff. Not quite as much runoff as West Lake goes into East Lake. It's not quite as big a catchment area, though now that they've built the new development, there's more runoff occurring into that one. The other thing, of course, is in the summer, it gets groundwater being pumped into it. So it's not as fresh, if you like, because it's getting all this groundwater pumped into it. And I've looked at some of the analyses that have been carried out. It's interesting that it doesn't have any times when there's no low dissolved oxygen. And I suspect it's because they're actually aerating it to some degree by pumping that water in. It's, it's a bit like when you've seen ornamental lakes and they have those pump systems going to try and aerate it to make sure that it doesn't become anoxic and horrible things happen. Of course, once the Herdsman main drain water comes in, it will mix up with whatever the water is in West Lake. It'll then come to those balance pipes, because remember, there's a pipe now connecting the two lakes, and then that'll get a mixture of what's in West Lake will also come into East Lake. So it gets quite interesting from a chemistry point of view. But again, I've gone through the data that's been collected leading up to this. It looks like the water quality in the main drain, West Lake and East Lake, is actually, there doesn't seem to be very many evidence of pesticides, herbicides, heavy metals, or even nutrients to some degree. So let's hope that the water quality is good and we won't have problems, major problems. Just conscious of the time too. We're about 3/4 of the way through. I just mentioned some work that Claire Tennant did. It's her master's thesis. We're now, if you look down here at the bottom, this is one of those transects. So we're going through East Lake all the way through to where it comes through Camel Lake. So we've got a cross section here of bores, and we got her to take groundwater samples and look at what was happening. Because the thesis was that as the lakes dry out and the sediments, or particularly the peat, oxidizes, then there will be slugs of nutrients being released into the groundwater table. And that's pretty well what we found. So in this case, this is phosphorus. The only high phosphorus level was in the surface water in the lake itself. We don't expect high phosphorus at all because there's limestone in this aquifer, and limestone takes out phosphorus. Nitrogen, you can see, particularly around Camel Lake, higher nitrogen in the groundwater, which is this sweating out of the organic matter. And chloride goes up as well because of the concentration effects. Okay. So we're up to 7. What's the quality of the lake flora and fauna? Let me walk you through this colourful slide. This is actually showing the canopy, the tree canopy. So everything that's coloured there is a tree canopy. Okay, you probably make out West Lake and East Lake. The different colours tell you what's happened to that tree canopy between 2016 and 2009, so a 7-year period. If it's yellow, it means that the tree canopy was there in both times, in 2016 and 2009. If it's green, it means that there's been an increase in canopy. So branches have grown or a tree has grown in that area. And if it's red, it means you've lost canopy. So this is tree decline, basically. Now, this area that's very red around here, this was the period when they were pulling down all the old stadium and things like that. So there's loss of trees there. This was the development of the new, the new Perry Lakes development. You'll see that around East Lake, the canopy was also affected, but a lot of this was actually deliberate. It was taking out the poplars that were there. Some of you might remember there were a whole lot of poplars and a few other exotic species there. They went in there and cut them out. Interestingly, this other stuff in between the lakes is actually the flooded gum parkland area. And it is looking surprisingly in good shape. It actually looks like, if it's anything, it's actually getting bigger rather than, there's not a lot of red in here. If you're worried about tree canopy decline, you might want to start worrying about what's happening out here in where we live, in our suburbs. And I've sent some things across to Steve Easton as well to have a look at what's happening in Bold Park, because there's some interesting things happening in Bold Park there as well, which we still haven't analysed, but hopefully we will do in the next year or so. So this is a program called Urban Monitor. Every summer we collect data. So I was with CSIRO when we started this program up. It's still being collected. So it goes back to about 2007, I think was the first time we collected this data. You can get an idea of tree canopy change over the whole of Perth. So my take home from this was that the flooded gum canopy is looking pretty good, and even the riparian canopy, we can explain if there are losses there, it's because of deliberate clearing of weeds. Now there's a GHD have done a monitoring of the flora and fauna assessment for the town of Cambridge. They did that 2 or 3 years ago. And they've assessed the status of the flora in the lakes and the status of the wetlands, if you like. It's red, it's completely degraded, which means that there's weeds pretty well taken over the whole thing. If it's orange, it's degraded. And if it's yellow, or yellowy green here, it's good to degraded. So there's only a small area around here where there's a bit of water left in East Lake that's considered to be of reasonable quality, because it's still got the existing, like the vegetation there. So this is actually quite damning when you look at that. You think, but when you go and look at it, and the people that were doing weeding, weeding through Friends of Perry Lakes will know that in fact there's an awful lot of weeds that have grown there. We've got a big job ahead of us to get rid of them. Some of them will go with spraying. There's been a lot of revegetation occurring in this area, and of course the water levels coming up will kill a lot of them as well. Now, the other bit of work that was interesting was the macroinvertebrates, which are the little critters that live in the water. They're an indication of whether you've got a healthy aquatic system. So if you have lots of them and lots of different types of them, then you've got a very healthy system. It's basically, in my layman's way of saying, what does macroinvertebrates tell you? So here we've got family diversity. So the more up here is good. The more families you've got, the more diversity you've got. It's a bit like biodiversity. And here you've got this other thing called signal score, which I've never heard of before, but I looked at the report and read it up a little bit about it. It's the health of the families of the macroinvertebrates on a scale of 0 to 10. So basically saying, if you've got a pristine river on the top of the mountains, never had any disturbance, you might get a 10. But you can't use it too literally, because you might have a really good system and it might only have a scale of 4 or 5 or something like that. But you can see that the scores here for macroinvertebrates are not very high. They're not getting up towards the 10s. They're down here. So we've got the best thing for a macroinvertebrate thing would be to be right up here in this corner somewhere. So the higher, the better. Basically, the consultants that did this work said you can't really separate the two lakes. The macroinvertebrate health of them is pretty similar. But within the lakes, you can see that some are better than others. So the Balmia in West Lake and East Lake are higher up than both these ones. Interestingly, the stormwater is much higher up here too. They could only get stormwater from East Lake, but the open waters were actually the ones where the least number of critters were. I don't know what that means. Maybe someone who's a biologist in the audience can tell us later on what it means. But it doesn't say at the moment that even though we've got very fresh water going in, particularly in the winter, that we've actually got a lot of macroinvertebrates in it. Okay, 8. Now we're getting down to what I've been talking to you a fair bit about anyway, which is what's the scheme to bring the water into the lake. So this is a map from a report by Rockwater, who wrote a couple of years ago. So here we have the Herdsman Lake main offtake up here near Newman College. It comes across Empire Avenue, goes down past the golf course, comes down here where I've got that yellow arrow pointing to. That's where the pipe system that they bring the water in stops, because it then can connect up to the street drainage system that the town operates, okay? So then it comes down through the street drainage system and goes into the northern part of Westlake, which is where that big culvert thing that I was showing you before. So this is how it comes in. So it gets pumped uphill to here, and then it drains under gravity all the way down here. And then there's this balance pipe between the two lakes. This is a picture of on Ulster Road, where they connect the two systems up. So this is near McFarlane Oval there, you know, where there's they hadn't connected it up here when I took this photograph, but you can still just see some you know, great inlets into the surface drainage system that they were connecting it up to. So the intention of the town is to have a target level of the lakes of about 3.8 metres above sea level. What does that mean? Well, here's some pictures of how much the lake fills up at different levels of elevation and water in the lake. So here we have East Lake. This is probably a little bit what it's like in most summers when they top it up. It's just this little area down here and in the southern part of it. If you get up to 3.2, you get about 50% coverage, sorry. And then if you get up to 3.6, most of its coverage. They're going for 3.8, so they're going to go for more than this, if you like, at the moment. That's the target. Whether they'll reach the target is still to be determined. And in Westlake, again, 2.8, 3.2, 3.6, you can see. We'll still have this little island here, which is an artificial island that was created well, at the time in the 60s. Okay. So the stormwater will come in, it's be pumped down. It's a matter of whether there's sufficient water in the main drain at any time to keep pumping, you know, whether they're going to be able to pump all through the year. And also they can't pump the water down if like in the next 3 days, I'm guessing this, I haven't spoken to them, we're expecting Monday, Tuesday, Wednesday to have front. So the street drainage system will need to be working really, really well. You would not want to have that street drainage system full of Herdsman main drain water at the same time. So there'll clearly be times in winter when they'll have to switch off the pumping system, which is a little bit of a shame because that's when the water level in the drain will be its highest as well. So there's going to be a little bit of finessing here. Yeah. Now, I won't go through this in much detail at all, but of course, before you bring the water in, you've got to do something about some of the weeds, and particularly some of the typha weeds, because if you don't get on top of that, then it'll take over. So basically, this is just a summary of what the Department of Water and Environment Regulation have come up with as a formula, which is to control the grasses, revegetate the lake, and the idea is to improve the water quality of the stormwater. They do know that there will be some particulates, so there'll be some suspended matter, there'll be some nutrients coming in that water. So you really need to somehow strip it out. So the formula that they're using is these ones here, you know, putting all these different types of things in the lake bed itself, on the banks and the riparian zones. And I won't go through all these different things, but those of you who are involved in the tree planting 3-4 Sundays ago will know that about which species they were putting in and where they're putting them in, because it was a very successful day. Now this is the map, which I hadn't seen until relatively recently, of where they have been planting in the lake beds. Okay, so this is a large area. So the water comes in to Westlake on the north here, and they've really got about the top third or a bit, perhaps 40% of the lake. They're revegetating that with the sedges. Then the connecting pipe here, or the balance pipe, will bring the water across into here. So where that water initially enters East Lake, it'll also be, there's be a bit of a filter system put in place. So that's the revegetation plan. This is the list of what's being planted. They've got irrigated grass. The idea is then that you'll go into a dryland area, the riparian zone, some submerged areas, and then open water. So this is the intention, that we'll have something there for all the different flora and fauna that we require for the lake. Okay, now will we have enough water in the drain to bring it down? So this is at the top here. Let's start at the top here. So the flow rate is here on the vertical axis from 0 to, what's that, 80 megalitres per day. So that megalitre is 1 million litres per day. So the blue line here is the mean for the period of monitoring, which is in this case between 93 and 99. So there's a lot of monitoring of main drains done years ago, and everyone said, no one's interested in the main drains. Let's stop the monitoring and save some money, which is what they did. So now people are really interested in what's in main drains because they can see that they want to use it for other purposes. So in 2018, the Water Corporation started remonitoring again. So this is what they've now found to be the flows. So this is between January and December, I should have said. We've got a median, we've got the minimum and the maximum for the particular month. And we've also got a little triangle here which says what's the minimum on a daily basis. So you can get some very, very low flows in certain days. When you combine them all together, you can see that between basically May through to about November, there's oodles of water in that drain. So that's the time you could probably safely take quite a lot of water out. But this is still going down to, you can see some of these levels are very low. They might be down to a few, 1 or 2 megalitres per day. How much water do we really need to fill up those lakes has really been the big question that that particularly was answered in this report. So they were looking at how much water would it require to take the water levels from where they are now to that 3.8 metres. When you looked at it, they believe that to maintain the water at lakes at 3.8, you need over the whole year an average of 2.6 megalitres. So that's quite reasonable. 2.6 is really quite low in the scheme of things. The minimum you'd need in September is 1.1, and the maximum if you're just going to do it, April would be the time you'd try and get as much water down as possible. And when you add it all up over the whole year, it's a little bit less than what they call a gigalitre. It's 1 billion litres of water. So you need about 1 gigalitre of water to keep the lake topped up to 3.8, both lakes up to about 3.8 metres for the whole year round. Now, probably not a good idea to have the lakes topped up to, maybe from aesthetics point of view, people love to see full lakes, but from a biological point of view, we're still to decide, if you like, or biologists are still to decide what the best thing is. Because if you can have higher levels in winter and lower in summer, that's what the biological system's more used to. So that seems quite feasible when you look at the numbers like that. The interesting thing is, of course, that over the summer, the Newman College have had a cut to their irrigation for their playing fields. So they're now is going to be starting taking water from the drain to augment their irrigation of the playing fields. So there's a little bit of potential for Newman College and the town to be looking at when the flows are very low, is trying to get that water, accessing that water. Now, what will be the impact on the groundwater, I guess? So this is also the same report. So this is saying how much will the groundwater levels rise as a result if you keep it up at 3.8 metres for 5 years. So this is actually, after 5 years of operating, a lot of that water will be going out through the bottom. It'll actually recharge the aquifer will come up. Basically, this is their estimates from their groundwater model, is that you'll get an increase of about 1 metre here, half a metre here, 25 centimetres here. So there will be a zone around the lake where the groundwater levels will come up, but not a large zone and not a very large amount. So Steve is probably looking at this and saying, well, where's Camel Lake in this? Well, Camel Lake may get a half a metre rise if this is correct, and they take it across about a 1 gigalitre and it settles down. I was a little bit surprised when I saw this because we've done a number of modellings for other schemes, apart from this one bringing the water down from Herdsman. We've actually come up with larger volumes required, and we've actually thought that you don't get a symmetrical rise in water level around the lakes. You actually get a banking up of groundwater on the upstream side. So I'd need to sit down with the modellers and just say, how did they arrive at these sorts of numbers? Because they do, I mean, everyone can have a go at models. They're just approximations, but I think there's a few things in this particular one that are a bit puzzling for me. So this is where we're getting to the unknowns. So we're up to 90% there. So you've done very well. I think most people are still awake. I think, yeah. So these are the unknowns for me. Okay, the model estimates you need about 1 gigalitre to get it to 3.8. I've said that several times. Other schemes I've seen where they actually put the water into the aquifer rather than the lakes to raise the groundwater levels, so that the groundwater levels then result in the groundwater coming up under the lakes and the lakes filling with groundwater rather than water from your drain or your wastewater treatment plant, has said that basically you need a little bit more than that. But maybe that's because you're putting it into the aquifer rather than directly into the lakes. There could well be that. But my gut feeling is that this could be at the lower end. I'm not sure. It could be that we might need more. We might need up to 2 gigalitres a year. Who knows? Until we do it, no one will know. But this is actually why I'm saying this is uncertain. And again, how much will the competition with Newman College be? Is it going to be important or not at certain critical times of the year? The other thing is that the model that they're using at the moment is relatively simple. They've done it, they've made some things. It ignores all the pumping that's happening around the lakes, apart from the pumping that goes, to augment the lake, if I'm reading it correctly. Now, you saw that cross-section before. The pumping around the lakes can be quite significant. It can have quite significant drawdown cones. So I don't know that ignoring the pumping from around the lakes is actually something you should be doing in a model like this, personally. And the other thing, which is perhaps the biggest worry, is that when you look at the calibration for the lakes, they've got this water level record from the lakes. Remember these ones from West and East Lake? And they've calibrated their groundwater models against the water levels in the lakes. And my feeling is the lakes are not connected to the groundwater anymore. So if they're calibrating against water levels in the lakes, it's not the groundwater they're calibrating in. Maybe they've calibrated with groundwater levels away from the lakes as well, which I would hope that they would. But if they've only calibrated the lakes, then they've really not got a calibration against the groundwater system. So this might be something that would be worth having a look at. The other thing is, the mitigating thing is that most people are assuming that the regional groundwater levels have been falling and they'll keep going. But I think we've seen from some slides earlier on that some good news there. It seems to be that it's stable or maybe even rising. And the other thing is that if you bring across a lot of water like that, and it's going to cost the town and ratepayers like me and you a fair bit to bring it across, and the groundwater levels rise, will it be required still that the town has to take a reduction in its pumping? Because at the moment, you probably know they're putting completely new retic systems in all through the area to try and improve the efficiency, to reduce the amount of water that they're using so they can meet their new requirements. I'm pretty sure this is what they're doing, because everyone's getting a cut in their irrigation. Now, if they are bringing a lot of water down and it's actually resulting in the groundwater levels rising, and they were rising anyway, I would, if I was on the town, I'd be arguing why are we getting a cut? Particularly, Alderby Reserve is really, really heavily used for all the sporting groups, and it'd be a pity if they have to actually drought out some areas there. I'm not sure whether they're planning that, because of a shortage of water, when it looks like there's enough water there and we're bringing even more water in. It just seems to me to be, everyone wants to do good water conservation, don't get me wrong, but if there's water there and it can be used and it cools things as well as allows kids to play and things like that, then why not use it? And also whether Camel Lake will be resolved. I can't tell you, Steve, whether Camel Lake's going to come back or not, but I guess no one does, but we'll have to watch this space. Now, the water quality uncertainties, how will biology, and this is going to be a future talk I think that Nikki is going to have to give us, is that if you bring in a lot of extra water, things have probably changed over 30 years of being dry. The water levels come up, they're much more stable. What's going to happen to tortoises, to frogs, to birds, to you name it? Those plantings that I showed you, will there be enough to strip out all the nutrients that are going to come in? The nitrogen, particularly the phosphorus. I don't know that there's a program there for bringing the phosphorus. Mostly when you grow things, and the phosphorus goes into a plant, you've got to harvest the plant and carry it away, because if you leave the plant there and it breaks down, it just releases the phosphorus back into the system again. So gradually you start getting more and more phosphorus building up, and it's the phosphorus that will cause algal blooms. It's not the nitrogen, it'll be the phosphorus. So that's still a bit of an unknown. When they diverted water from this same drainage system, it's the same herdsman drainage system they diverted into Jackadder a number of years ago. there was algal blooms occurring of that same system. I haven't gone into the details of that, but if that happened there and we're going to be doing the same thing, then maybe we'll have the same problem that Jakarta had. They seem to have got on top of their problems. It'd be nice to know what they did. The fact that we've got higher water levels, what are the positive and negative health implications? Obviously, presumably people will start doing a lot more recreation around the lakes. You know, there'll be a lot more physical and perhaps mental health things, but there may also be issues of mosquitoes, you know, toxins, botulism, you name it. There are other things that can come in when you introduce nutrients and stuff like that into the lakes. And the other thing is, this is something that Nikki brought up, I think she's on one of these advisory committees, is that Perry Lakes has been pretty well isolated from all the other lakes on the coastal plain, okay, for the last few thousand years. We're now going to connect it up to the Herdsman Lake system. Now, what's in Herdsman Lake? What organisms, what chemicals, what sort of, you know, carp or whatever it is, what's going to be coming in? Now, I know there are gross pollutant traps between us and Herdsman Lake that will actually filter out some of those things, but I think it's still a bit of a question mark in my mind as to what might happen. So I have got some conclusions. This is pretty well the last slide, apart from the last slide with anything in it. So I think we need to correct the misperception that Perry Lakes is closely connected to the superficial aquifer, at least at the moment. It seems to be that the aquifer's fallen below the bottom of the lake. That's my impression. And that the groundwater levels are falling and they're continuing to fall. I think they're pretty well stabilised. I think I've banged on about that often enough. Now, the thing is that the lakes are apparently not very valuable from a conservation perspective. So if you look in there, you see all these weeds and things like that, and maybe there's not as many birds as there used to be and those sorts of things. But I actually am this is my impression, they could become one of the most valuable lakes on the Swan Coastal Plain because it's going to be the only lake where you can actually raise the levels. You can alter the levels to be what you want. So if you want shallow water, you want deep water, whatever it is, all the other lakes are dependent on what comes off the roads and what rainfall occurs. This will be one of the very few ones where you've got a lever that says, want more water for a critical species, you want to breed, I don't know, some duck or something like that, switch the pump on a bit heavier and you've got more water in there. So this could become also very influential. If they start doing this in other wetlands around West Perth, this could be where they do the measurements. This is where we do the learning from, if you like. And the hydro period. The hydro period is just a fancy name for what water levels do we need at different times a year to optimize things. Now, some people will be wanting to optimize for biological things, but there's also aesthetics. There's you know, all sorts of things. You might want to manage mosquitoes or something like that. So there's still uncertainties about what the water is required, how much we need at critical times a year to get, you know, and I've got in here economic needs. Actually, having water in lakes has huge impacts on property values around as well. We've got some really hard numbers on that. It's very substantial. If you looked at all the lakes around Perth and you looked at the increase in property values by being close to a lake, it comes to $4 billion. It's been done. The economists have looked at this. It's huge. It's not as much as being close with a view of the ocean or the river for that matter, but it is still quite substantial. So if we're going to optimise it, we really need to monitor what's going on and manage water. The risks, to me, they do seem quite manageable. I mean, we're not bringing water of very, very poor quality down, but no one really knows what's going to happen, I think. But so we really need to do a lot of monitoring and management over the next 3 to 5 years. It'll be interesting to see what happens. And this is one of the reasons why I'm very keen to be involved in the Friends of Perry Lakes, and I'm glad to see that so many of you are here, is that we're going to help the town, I hope, and the broader community make the most of this opportunity by controlling some of the weeds, you know, replanting things, monitoring what's going on. And finally, we've got Charlie here, who's Charlie Bond, who's actually got about 40 master's students here from UWA, all wanting to work on Perry Lakes and a couple of other areas around here. And they're wanting to dive into this data and lots of other data. There's lots of other biological data I haven't shown you tonight, to start assembling it all into big databases and analysing it. And they'll get training out of it, but they'll also be interacting with the friends of groups, the town, Department of Water and Environmental Regulation, and Bold Park as well, the Botanic Gardens and Parks Authority. So it's really quite exciting what's going to happen between now and it's about November. Is it? They're all going to come up with these reports, Charlie? Is that?
Yeah, that's right.
Okay. So we've got some horsepower coming over the hill. So that's it. Thanks very much.
Happy to take some questions.
Mm-hmm.
Let you share your...
Okay, have we got any questions? Yes.
So you talk about terrain being able to turn on and off a bit.
Mm-hmm.
If we stop it, does it still burn at 40 feet? Is that...
Yes. Yeah, the Water Corporation are very careful, so they won't block it off. They will always have that as a, you know, if, for instance, we don't need the water or they will always keep that open, almost certainly. Yeah, so, yes.
Is the reduction at Newman College that you were saying was a general reduction around because of lack of water?
Yeah.
And if so, is it what sort of reduction is that?
Good question. I think, sorry, the question I'll be repeated because we're actually recording this. What is the reduction that's expected at Newman College? I think it's something like 10%, might be up to 15%. Everyone's expected to find this. There's a new Nangara groundwater management plan that's just been announced by the minister about a few months ago now, and he's expecting everyone to cut back, all licensed holders, or pretty well all licensed holders, to cut back by about, I think it's 10 to 15%. There's also, those of you who've got backyard bores will have heard that, you know, you're going to go over 2 days a week restrictions and a few other things happening as well as a result of that plan. I'm not sure how much of that water that means, how many megalitres that is that the Newman College will be diverting. Right. Okay, the question is who? Yes. Okay, and the question is who's managing the levels? The town, basically. So that this is an area I should have mentioned, perhaps is vested in the town. The town have spent, I think it's close to $3 million on putting this scheme together with all the consultancies and the pipe work and the pumps, and there'll be an operating cost, obviously, because they'll be taking power to operate the pumps and they'll be doing monitoring. So it's coming out of our rates. There wasn't any grants from anywhere else that I'm aware of, and they are the ones that decide what the levels are going to be and how much pumping is going to occur. Unless something happens from an environmental point of view, in which case one of the state government environmental agencies might get involved, but it's really up to the town. Yes, at the back.
You mentioned that the biodiversity in the lake is relatively low. Do you know if much of that's endemic, native, or a lot of it is introduced? Do you know much about that?
I'm not an expert on that, and I think you could get an argument as to whether the taifa is native or whether it's actually introduced. There's two different schemes there, but I think the thing was that as the taifa as the lake has dried, particularly the taifa has expanded, so it's becoming more of a monoculture than it was. It was more mixed before. So even if it is native species, they're getting a little bit out of balance. I think they would like to get some more Baumia back because the western swamp hen, I think, likes it for nesting and other things. And I'm looking at the bird people in the audience. I think that if you have more of a diversity of reeds and bulrushes and things like that, it's better for the biology. But almost certainly one of the things that the students will be looking at is what's happened to the water birds, the number and species and what they've done as the lakes have dried. So there are some data that go back decades as to what use of the lakes the birds have made. It'll be really good to put those data sets together, the lake water levels and as they've gone down and what birds have done, and they've abandoned the lakes and gone somewhere else. And it'll be very interesting to see whether as the levels come back up again, whether the birds recolonise and start using Pear Lakes much perhaps as they used to use it in the 70s. Good question. I've not seen it. Maybe Nikki's been on the management committee, but I think it's an aesthetics thing. I might be speaking out of turn here, but I think that now that there's so many people living next to Perry Lakes and paying rates, there's a requirement, I think, to have water in the lakes, to have a lake view, and basically for people to walk their dogs and see open water and things like that. Because I didn't talk about the bathymetry too much, but the lakes are very varied. So even if it is 3.8, there will be large parts of the lake which are actually relatively shallow still. It doesn't, there'll still be emergent islands on the lake. So if there's a Those islands were initially created for refugia, for things to nest there, to keep the foxes and cats and dogs away from them. So even at 3.8, which seems quite high, there'll still be emergent areas there. But I think from my feeling is that maybe the lakes levels will go up and down, I suspect, with the late summer period being when they're the lowest, and the late winter area, because there's always the groundwater has a bit of a lag associated with it. The lake winter area will be when it's its highest, which is what the natural system is. Yes.
Yeah, you said that to maintain that target of 3.8, the modelling showed roughly 1 gigalitre per hour. And you said you thought that was at the lower end of the scale. But with the amount of water that's available from the system, even if that was doubled to 2 gigalitres a year, are you comfortable that there's sufficient water in the system to do that?
Well, it looks like it from those plots, as you say. Sorry, the question was, is there enough water in the drains, if you like, to keep everyone happy? So there's enough water there for Newman College to take water out, and there's enough water there to keep the lakes at 3.8. I don't know that anyone can absolutely be sure. It looks like the flow in the drains pretty well stabilised. If you look at the late 90s and the more recent monitoring, it seems to be that the water in that drain is now pretty well stabilised. So if it stays at that, that should be fine. And if the regional groundwater level around the lakes is not falling as well, one of the concerns would be that if the groundwater levels around the lakes were falling, then you'd have to keep bringing. So it wouldn't be 1 gigalitre. It'll be, in 10 years' time, it might be 1.5 gigalitres. Because you're fighting against the drying climate. So that's why I'm moderately optimistic. It looks like there's enough water in the drain. It looks like the groundwater levels have stabilised. So whether it's 1 gigalitre or 2 gigalitres, the main difference may be how much it's going to cost to pump it down. That may be the big thing. And I'm looking at Nikki here because she's been on the committee that's sort of looking at all this, but I'm not sure I've seen the costs of what the pumping costs are going to be. Have you seen this?
No.
Okay. So there will be a pumping cost of doing that because you do have to pump. A gigalitre is a lot of water, and you've got to pump it uphill to get it over that divide.
So that was extremely comprehensive, John, but one thing I noticed you did discuss was the background to what the council has been occasionally planning to do to restore water to the lakes. You know how there's been, over the last 20 years, there's been various attempts to do this with alternative options. Maybe you could just touch on that big option that there was using the water treatment, just to fill us in a bit.
Well, every time you think that you've come up with a solution for Perry Lakes, someone's done it and thought about it 2 decades earlier. So that idea of bringing water down from the main drain was done, as I say, by the Perth City Council before even the town of Cambridge was developed. Oh, here we go. How did that come up? Oh, that's spooky. So basically, this was a scheme that.
I promise I didn't plan that.
This is so here we are with West and East Lake very clearly marked. CSIRO, which was where a number of us, like Ollie and I, worked for a number of years. We've got the Subiaco wastewater treatment plant, and this is actually producing. We talked about bringing 1 gigalitre down from Herdsman. I think it's about 25 gigalitres goes offshore. So this is highly treated wastewater that gets pumped off here in this blue line going all the way off here. And here, this orange line is actually existing stormwater drain. You said, I said that there's a pump station here, and it brings stormwater down. It connects onto this orange thing, which goes out. The stormwater drain goes out onto the beach. Now, what the scheme we had over 10 years ago now was to actually do further treatment of the wastewater treatment plant water. So that was doing some more filtration systems, so it becomes even cleaner. So it almost looks like pure water. There's about 150 or 200 metres of pipe to connect it up to this drainage system, and then to pump the water back uphill, like back up to the lakes. We pressure tested that pipe and it's perfect. It could work, so you could bring it up, and therefore, for the cost of that little bit of piping there, you would be able to take the water into the reserve. Then the suggestion was that you'd actually put it into infiltration galleries downstream from the drain, from the lakes. We weren't going to put it into the lakes because we thought that would be a bit dangerous because there's nutrients and pathogens and all sorts of things in it. And so there were infiltration galleries, and a lot of work was done to look at what sort of galleries, where would you put them, how much water would you put in them. And then the idea was that the groundwater levels would rise around these galleries, and then the groundwater that's flowing out to, see this is where the blue line is, this is where the groundwater flows out under Wall Park, that would actually build up against a barrier from the water that's going in through these infiltration galleries, and gradually the groundwater would actually come up underneath the lakes and fill up the lakes. So when we did this modelling, it turned out to be about 1.7 to 2 gigalitres was required to bring the system back. One of the advantages, or several advantages of that, is that you don't have to pump much water because it's very close. As I say, you don't have to build very many pipes. You actually increase the groundwater, and you increase the groundwater over a large area, not just this area around the lakes, but it would actually bank up many kilometres further back from the lakes. So you'd actually increase the people that, you know, the council and also the people with backyard bores that might want to use groundwater. You wouldn't be putting it directly into the lakes, so therefore they'd be filtered before it went in there. You'd be diverting wastewater that would have been going offshore. And it costs a lot of energy to pump that water offshore. So the Water Corporation agreed that the cost of pumping it across to the lakes would actually be offset because they wouldn't have to pump all that water all the way offshore. So there was lots and lots of pluses. The other 2 or 3 pluses were it was all going to be funded by the federal government under the RUD scheme. There was also money going in from Landcorp because they would put water into these lakes and they could sell the land here for much more because the lakes would be full. It would be testing using wastewater treatment to recharge aquifers, so it would become a bit of a test case for that. And when I was at CSIRO there, we managed to get money for 3 years to do a monitoring and fine-tuning of the system. Unfortunately, the then council, I don't think there's anyone left on the council now that were there, they decided they didn't want to go ahead with that scheme and they handed all that money back. So that scheme, and now they've gone for this one for bringing water down from herdsmen, all paid for out of ratepayers funding, and all the maintenance costs will be out of ratepayers funding as well.
Revisit that scheme.
Good question. And if there were major problems with, let's say, problems getting water out of the main drain, then this scheme is sitting there. It's all been designed. In fact, it was pretty well shovel ready at the time. It might have had 1 or 2 regulatory things to still go through, but all the design of the filtering system at the Subiaco wastewater treatment plant, the design of all the infiltration galleries, the optimisation of the galleries, and the water going off from here has never been, you know, still growing, actually still increasing. So this is an increasing resource going offshore. The other one, while I've got it up, was one I toyed with a little bit. I looked at, I've managed to get the Water Corporation to monitor the flow in the Subiaco main drain. So this is just the same water, pretty well the same sort of water that's going out through herdsmen. It's not enough volume, but you can see it's already connected up to the lake system. You could get, I can't remember now, but I think it's something like 150 megalitres a year if you wanted to, but it wouldn't be enough to fill the lakes. But that would be the easiest thing because at the moment we're chasing the same quality water kilometres away. So that was, thank you, Nikki. So are there any other questions? Otherwise we'll...
Do you have any more slides?
I'd had to put a few more in there, but I think you've suffered enough.
All right, well, thanks, Don, for an amazing, I don't think anyone else is going to become education officer, sorry.
Or treasurer.
Nobody can do that. So, thanks, Don's done a lot of research, he does know an awful lot, but he's also spent a lot of time getting this one ready. I think he's enjoyed it. But,
Yeah, thank you.
that was amazing, and we've recorded it for posterity, hopefully, so probably on our website in the future. So, next education event, I think is a bird.
Yes.
Don's the education officer, so you can explain.
Yeah, I've got to try and remember. I think it's the 21st of August. There's a few people here that are going to be leading it, Viv and Ollie. Do you want to stand up, Viv and Ollie, so they can all see you? Everyone knows these gentlemen. They'll be leading on the 21st in the afternoon, I think it is, isn't it? It's a Sunday afternoon, probably about the same time as we came here, about 4 o'clock. So it'll be an observe, trying to find out which birds are there and what they're doing. And Viv is in BirdLife WA, and Ollie's a person who lives on the lake that looks at them all the time. And I think you did some bird observing when you were in zoology in 20 something years ago, wasn't it? So this is part of he's part of the collection of the data we've got on birds on the lake. So, and then after that, I think we've got something in September about frogs. Is that right, Nikki?
Maybe, yeah.
Maybe.
Some night walking.
So we're going to listen to frogs and try and identify frogs and find out what the heck they're doing. So thanks very much for coming. I really appreciate it. Yeah.
I've got some flyers here for there's a picnic in Perry Lakes Park on October the 31st, and everyone's invited. It's late afternoon, 4:30 p.m. Sunday the 30th of October, and it's put on. I must admit, it's put on by the local real estate people, actually consolidated the who's heirs who probably sold most of it very late block. And but it's a community event, so anyone who lives around Perry Lake, so it's a good opportunity. There'll be, I think they're putting on pizzas and there's activities for children, and there's a band playing of local residents who will be providing music. So it's an afternoon. So I've got some brochures for you, some of the like.
Adam, yeah, thank you.
Did a recording while we're from them now.
Oh, yeah.